the last thing we're going to look at is 6.5 part 2. And we're going to start out by solving triangles. So the idea of solving a triangle means to figure out all the sides and all the angles. So that's 6 things. 3 sides, 3 angles. But we're solving right triangles. So what do you automatically know? Yeah? Yeah, you know one of the angles, it's going to be a right angle. So there's one thing you already know. And in addition to the right angle, I need to give you some other information. There's 2 cases that you could have. I can either give you, in addition to the right angle, one of the other angles and the length of one of the sides, or I can just give you 2 of the sides. Depending on which case you have, it's going to change how you solve. Okay, so the point is, bless you, you'll always know 3 things. You'll always know 3 things. And you're going to have to find 3 things. Remember when we're finding sides, what do we use for the labels for the sides? Yeah?
A, B, and C.
A, B, C. And what do we use for the names of the angles that we don't know? The Greek letters. And the one across from A is? Yep. Alpha. And across from B? Beta. Yep. So keep in mind as we go through this, the Pythagorean theorem is something we can use. And all the angles in a triangle need to add up to 180 degrees. That's another fact that will help us. Now, my general suggestion when you're trying to solve a right triangle, don't use something that you calculated to then try to find something else. Why not? Why would you want to use something that you figured out to find something else you don't know? Yeah? Right. Because if you use something that you got wrong to find something else, then you're going to get that wrong. So when we solve, we're always going to go back to the information that was originally given in the problem. Always. All right, so how do we solve? Well, we're going to have to use a trig function. The only 3 that we're going to use today are sine, cosine, and tangent. The reason is because that's what we have buttons for on the calculator. We don't have a secant, a cosecant, or a cotangent. So to try to use those, it's more complicated. Okay, so we're going to stick with one of those 3. And the way that you figure out which trig function to use is you have to look at the sides that you're using. If you know the opposite and you're trying to find the adjacent, you'd have to think which trig function has opposite and adjacent. That's tangent. If you know the opposite and you're trying to find the hypotenuse, let's say, okay, I know the opposite, trying to get hypotenuse. Which trig function has opposite and hypotenuse in it? Yep. Sine. So the way you figure out which one to use, you look at your diagram and figure out the names of the 2 sides that you're looking at in the problem. Okay, but it's always going to be one of those 3. Let's try an example. All right, so this says one angle in a right triangle is 37 degrees, and the hypotenuse is 8. Solve the triangle. Okay. In order to visualize what's opposite, what's adjacent, and all that, what do you think it is helpful to do every time we're solving a right triangle with all the information they give you? Yeah?
Should we first take note that the other angle is 53 degrees?
Okay, so we can calculate the other angle pretty easily. But before we do any calculation, something else we should do. Once we start calculating, though, that'll be the first thing we do. Yeah?
You want to draw out the triangle to start off.
Let's draw it out so we can see what's opposite and adjacent.
It'll make everything easier to look at.
Yep. Okay, so they tell me one angle is 37. And then they tell me the hypotenuse is 8. Okay, what we should do to keep track of things is label this. Let's call this side A, B, and C. What angle does that mean the 37 is?
Alpha.
Yeah, 37 is going to be my alpha. And the angle up at the top? Beta. Okay, so what I do off to the side is I make a table. Put your 3 sides in one column. And then your 3 angles in the other column. You don't really need a name for the 3rd angle because it's always the right angle. Okay. And let's start filling everything in. Do we know A? No. So let's put a box around it because we need to figure that out. Do we know B? No. Let's put a box around that. Do we know C?
Yes.
Yeah. So we don't need a box because we're not finding that one. Do we know alpha?
Yes.
Okay, so we got that one. And were we given beta?
No, we
No.
found it.
It's
Yeah.
Like there's 180 degrees in a triangle, and since we already know there's 90 on the right, since it's a right triangle, you know there's 90 degrees left. So you do the 90 minus 37.
Yep. And 90 minus 37 is
53.
53. Yeah. Okay. So that's generally the easiest thing to find because you just have to subtract 37 from 90. So any question on that? Now, to do the rest of the problem, we need to use an angle as our point of reference. Which angle should we choose as our reference point? Yeah. You can't choose the 90. You have to choose an acute angle as your reference point. Yeah.
I think that it would be easier to work with the angle that we were given first, which
Yeah.
is the 37.
Right. So for the rest of this problem, we're going to forget about the 53. We have it, we found it, we're done with it. Don't use the 53 to figure out anything else. Because if it's wrong, you're going to mess up everything. Right. So we're going to stick with the 37. So from the perspective of the 37, what is the name, or what's the position of side A? Yep. This is opposite. What's the position of side B? Adjacent. Now, depending on what we want to find, we have names. Okay. Bless you. Let's find A first. Yeah.
So in that case, that would be the sine of 37 equals A over 8.
Yes. If we're going to solve for A, A is the opposite. The side that I know is the hypotenuse. So I want the opposite. I know the hypotenuse. The only trig function out of sine, cosine, and tangent that has opposite and hypotenuse is sine. Yep. So you write sine. What gets plugged into a trig function as the argument is the angle. So it's sine of 37 degrees equals opposite over hypotenuse. What's opposite 37? A. And what's the hypotenuse?
8.
8. And how would you get A by itself there?
Multiply by 8.
Multiplied by 8. Okay, we do have to type that in and round it off, but that's what you're going to type in. 8 sine, and it's the sine of what?
37 degrees.
37 degrees. So make sure on your calculator, you need to be in degrees. So mode, let's see, degrees, And then if it doesn't say degrees at the top, you're not in degrees, so make sure it says degrees. 8 sine 37. Okay, so A is, we're going to go 3 decimals, 4.815. 4.815. Okay, now we've got 5 out of the 6 things. We need one more thing, which is B. Yep.
This one's going to be easier to deal with because we already have A. So we square, we do the
Pythagorean theorem.
Pythagorean theorem. Okay, well, we could. Why do you think I might be a little concerned about using Pythagorean theorem? Yeah?
Because if we made a mistake in solving A, it would lead to us making a mistake in solving B.
Right. The goal is to never use something that you calculated to find something else. So I would find B the same way we found A. Let's use a trig function and go back to the 2 pieces of information that were given, the 53 and the 8. So let's put this over here. Okay, so find B. What side is B in the triangle?
Adjacent.
It's adjacent. And what's the side that we were given? What position is it?
Alpha.
Position, not name. Yeah. We weren't given the side across from the 37, though. So we're trying to find the adjacent, and then I asked what side was given.
Oh,
The hypotenuse. Yeah, the hypotenuse. So we're trying to find the adjacent. We know the hypotenuse. Which trig function has adjacent and hypotenuse in it? Yep. Cosine. So this time you need cosine. And we're doing everything from the perspective of the 37. And cosine is adjacent over hypotenuse. B divided by 8. Same thing to get B by itself. And your cosine, your B is 8 cosine 37. So 8 cosine 37. So 6.389. Okay, quick thing I always do is look at it and make sure the biggest side is across from the biggest angle and the smallest side is with the smallest angle. In triangles, that's always supposed to happen. If it doesn't, you did something wrong. Okay, but that works here. Yeah.
Would the tangent of 37 with 4.815 over B also work?
Well, if we use tangent, then we're going to be using a side that we calculated. And if we made a mistake, then B is going to come out wrong.
Oh, okay.
That's the only reason why we didn't do that. And 4.815 is not an exact answer.
Yeah.
So even if it is right, you're using something rounded. We generally don't want to do that either.
Yeah.
Okay. All right. So any questions on how we got the A, the B, or the beta? So not really a lot of. There's 3 things you got to find, but there's not really a lot of steps in each one of them. They're all pretty quick. Yeah, let's try this one. So this says alpha is 20 and A is 12.3. Okay. Does it matter where I put the alpha? Like in the top or in the lower right? Does it matter?
I mean, it would be the same triangle.
It's got to be the same thing. It doesn't. You can put the 20 wherever you want. I mean, you can't put it as the right angle. That's already taken. But you can put it in the top or the bottom. Once you decide where to put that, now it matters where you put the 12.3. Where does the 12.3 have to go now?
Across.
It always has to go across. Because A always goes opposite alpha. That's That's the convention. Okay, so let's make a table. A we know is 12.3. B and C, we don't know those. Alpha, yep, that's given. And is beta given?
No.
No, beta is not given. You can find any of the three things you're missing in any order you want. It's not like one depends on the other. We're purposely avoiding that. Okay, so I generally do the quickest one. So I think beta is the fastest. What's beta?
Beta is the second angle.
Yep. And how much is it?
Well, it would be the cosine of beta equals 12.3 over the hypotenuse.
Okay. Is there another way we could find beta without doing any trick?
Oh, well, the other side would be 12.3 because this is a right triangle, right?
That's the key. It is a right triangle, yes. We don't have to think about any sides to find beta. What do all the angles have to add up to?
180.
Yes.
Oh. Yeah,
Yeah.
that sounds easier.
So what do you think beta would be?
70.
70. We know that we already used 90 up for the right angle, so the other two have to be complementary. Okay, so we've got beta. Now to find B and C, we have to use trig. Doesn't matter which order, let's do B first. Unless anyone wants to do C first. So let's find B. We need to figure out what the name of side B is. So this is A, this is B, that's C. Everything is going to be from the perspective of which angle? Yep, the 20 degree, because that was the given. So what is side B? Or what's the position? Yeah,
Adjacent.
that's adjacent. And that means side A is
Opposite.
opposite. Okay, so to find B, B is adjacent. And what's the side, what's the position of the side that we already know?
The opposite.
We know the opposite. We want the adjacent. So which trig function would you use?
Tangent.
Tangent. Yep. Opposite and adjacent. Okay, so it's going to be tangent of your angle equals, now fill in opposite over adjacent. Opposite is 12.3, and adjacent, we don't know. Okay. Yeah.
For what we're going to need to do here is get the B by itself.
Yes.
This is a very easy process because of how moving things would be. We can just swap B and tan of 20 degrees
Yes.
because of
Yep. You can swap the B and the tangent 20 degrees.
you'd have to multiply B to the other side, but then you could divide by tangent of 20 and bring it over to the other side.
Yep. So if you want to see why you can just swap the B and the tangent 20, it's because you can multiply both sides by B. That puts the B on the other side, gets rid of it next to the 12.3, and then you can divide by tangent 20. And now you get B equals 12.3 divided by the tangent of 20. So that's a pretty general rule. Anytime you've got something like, you're trying to solve that equation for x, you can just swap the 3 and the x. That works in any proportion that's similar to what we're doing. Well, not proportion, a fraction. Well, it's kind of like proportion. Okay, let's type that in. So 12.3 divided by tangent 20. Make sure you're still in degrees. And you get 33.794.
I think we made a mistake.
I made a mistake. It's possible.
Wait, I think earlier when you had said something, you had mentioned when you had said. Can you scroll up to the question? Oh, I made a mistake. Never mind.
All right. So now we want to find C. Could use Pythagorean theorem, but we're going to stay away from it because B is rounded and we made a mistake.
No, I just made a mistake. Because it was the letters. The way I wrote it is that A and B were different. I put A and B on the sine cosine thing, but the way I'm doing it is that A is that because of the spot where we're doing it, A and B for me will be swapped.
Okay. Yeah, you can do that. You should still get the same answer, but yeah, you can do that. All right. So now that was find B. Let's find C. Still using the 20 degrees. What position is side C? Yep. All right, so now we're trying to find hypotenuse. And we were given opposite. Which trig function has those two? Hypotenuse and opposite. Yeah. Sine. Yep. So it's going to be the sine of, what am I going to fill in for my angle? 20 degrees, yep. And what's going to go on the other side? Yeah, that's 12.3 over C. This time, I'm just going to use the trick I showed you. Switch the sine 20 and the C. And we get 12.3 over the sine of 20. Let's see what we get. 12.3 divided by sine 20. So we get about 35.963. 963. Okay, biggest side should be across from the right angle. The smallest side goes with the smallest angle. Okay, looks good. And the other thing that should always happen in a triangle is any two sides added together should be bigger than the third. That always, it has to happen. And if you add any two sides here, that looks good. Okay, any question on that type? So pretty much the same as the last one. They give you a side to start, and they gave you an angle to start. When they give you two sides to start, it's different. What do you think when they give you two sides to start? What do you think I'm going to be okay with you using this time that I wasn't okay in the first two problems? Yeah?
Pythagorean theorem.
Yes. You can use Pythagorean theorem because you're not plugging in anything you found. You're going to plug in all stuff that was given. Right. So let's do that first. Okay, so draw your triangle. They don't tell you which side is A and B. So you can put either the 6.1, let's see. Well, they do tell me one of these numbers is the hypotenuse and one of them is a leg. Which of those two numbers has to be the hypotenuse? It has to be the 12.7. And now they don't tell you where the 6.1 goes. It's a length. It could be A or it could be B. On the test, I'll be specific. So that way it's easier for me to know what you're finding. Okay, so I'm going to make it, I don't know, what do you want to make it, A or B? For the bottom. Okay, we'll make bottom B. So that's going to be B. That's going to be A, C, alpha, beta. Okay, so using Pythagorean theorem, what side can we figure out right away?
You get A.
Yep, we can get A. Okay, I should make my table so I got a place for everything. So B is 6.1, C is 12.7. Okay. You know what? I'm gonna find A. I need a little bit more space. Right, so what would be my equation I would set up to find A? Yep.
You do C squared minus B squared equals A squared.
Okay, and can you go ahead and just fill in those numbers for me?
12.7 squared minus 6.1 squared equals A squared.
And then to get A by itself, what are we going to do on both sides?
Square root it.
Square root. This is really the best way to do the problem. So you're not doing any rounding until you're going to type the answer in on the calculator. Okay. If I square this and round each one, then subtract it, then round it again, we'll take the square root and then round it again. I've rounded 4 times in the same problem. That's not really the best way to do it. Okay, so we're going to type in the whole thing just like that. So square root 12.7 squared minus 6.1 squared. So 11.139. And that's the only rounding that I do. Okay, any questions on that? All right, now that we've got A, we're going to forget about it. We're not going to use it. We have to find alpha and we have to find beta. Can we just use the fact right away that all the triangles add up to 180 and figure one of them out?
No.
No, because we're missing both. Doesn't matter which one you do first. Let's try alpha. Okay, so let's look at our triangle. Everything is going to be from the perspective of alpha. And what's the position of the two sides that we know relative to alpha? Yeah.
Adjacent and hypotenuse.
Yep. This is adjacent. This is hypotenuse. So which trig function has adjacent and hypotenuse in it?
Cosine.
Cosine. All right. So this time it's going to be cosine. What am I going to fill in for my angle? Yeah.
6.1 over 12.7.
But first inside the parentheses.
That would be the alpha.
Alpha. Yep. So alpha goes inside the parentheses. And then we do adjacent over hypotenuse. What's different about this? This is the first time we've had this happen today. Yeah?
So you don't know what the angle is, so you're going to do the inverse operation.
Right.
Answer like 6.1 divided by 12.7.
Now we don't know the angle this time. And the angle is inside a function. So the only way that we can get the angle by itself is to do what I'm about to show you. So to finish solving this, we got to get rid of the cosine function. So we need a function that undoes it. So we've seen examples like when you square root, right? Cube root. Cosine is a function that undoes it. Yep.
Inverse.
Inverse cosine. Yep.
Or secant.
No, that's a different trig function.
Oh, okay.
So there's a difference between a reciprocal and an inverse.
Oh, okay.
Okay? Even though the notation here, this -1, usually when you put a -1 on something, it means reciprocal. That's what it means. But when you write a trig function and you put a -1 in this spot, it does not mean reciprocal. The -1 is a special symbol that means inverse trig. So again, usually -1 means reciprocal. It does not in that case. It means inverse trig. And when we write inverse trig, we're going to use that symbol. Okay? Sine with a -1, cosine with a -1, or tangent with a -1. But there is another way that you can write inverse trig. And it's called arcsine, arccosine, or arctangent. It's just a different notation. Okay? It's the same thing. So all we really need to know about these today is that inverse trig cancels out a regular trig function. So we use it the same way you would use like a square root. Okay? If you had this, to solve it, you would take the square root of both sides. Well, when you have this, you're going to take the inverse cosine of both sides. Just like this. So inverse cosine, and you're going to fill in everything that's on the left. Inverse cosine. And we're going to do what's on the right. Yeah, I did. I ran out of space. So the inverse cosine of 6.1 over 12.7 and the inverse cosine of the cosine of alpha. I just used a bracket here because I had used a parenthesis already right there. That's all. So what do you think happens when I take the inverse cosine of the cosine? Yeah?
Just cancels and using alpha.
Right? They cancel out. There's no multiplication happening on this left-hand side at all. Just to be clear about that. You're not multiplying anything together. You're plugging cosine into the inverse cosine. This is an argument to the inverse cosine function. Okay, and when you plug that in, it cancels. And now we get inverse cosine of 6.1 over 12.7. Okay. To do inverse cosine on the calculator, press second, and then press the cosine button. That's how you do inverse trig. Press second, and then the trig button. Okay, so we need 6.1 over 12.7. Okay. So how should I write that answer? Yeah?
It would be 61.29 degrees.
Yes. So I'm going to go to 3 decimal places, but you said the important thing I was looking for. That is degrees. Inverse trig is always used to find an angle. That's why you use it. Inverse trig is used to find an angle. So 61.294 degrees. Okay, and I'll put that up in our table. All right. Now we know that alpha and beta are supposed to be complementary. So should we just subtract 61 from 90?
No.
No. Because if we messed it up, we're going to mess beta up. So let's find beta the same way. Okay, so find beta. Notice what we're doing now. We are switching our perspective in the triangle. We're no longer working from alpha. Now we're working from beta. So this name doesn't work anymore. What's this side now?
Opposite.
Now it's opposite. Now, I didn't cross out hypotenuse because even though we're switching our angle, the hypotenuse is still across from the 90. Okay? So what trig function are we going to use to find beta? Sine. We need opposite and hypotenuse. So the sine of my angle equals 6.1 over 12.7. Now we should have an idea of what it's going to come out to. It's got to add up to 90. So it's going to be about like 29, well actually 28.7, right around there to add up to 90. Okay, what do we have to do on both sides to get rid of sine? Yeah?
Sine -1.
And what are you doing with it? Can you give me a verb?
Applying it to both sides.
Okay, yeah, just as long as you don't say multiply both sides by inverse sine. You can't, that doesn't work.
Why not? Like, is it like you divide it, or?
No, it's not arithmetic. It's kind of like if I said this and you said, oh, multiply both sides by the square root. You're not multiplying both sides by square root when you solve that.
You're square rooting it.
Right, you're taking the square root of both sides.
So, like you said, arc sine or arc theta, or arc cosine is like the proper name of it. So, what do you call the proper verb arcing?
No, I usually just say take. Take the inverse sine.
Take inverse sine.
Yep, take the inverse sine of both sides. When you do that, it's going to cancel out the regular sine, and you're left with the angle by itself. So inverse sine of 6.1 over 12.7.
So you get 28.7.
Yeah, 28.706 degrees, right? That's an angle. Okay, I'm just going to put it up in the table. 28, 706 degrees. Any question on it? Alright, so the only time you're ever going to have to use inverse trig is if they start you with two sides. If they start you with a side and an angle, you don't need inverse trig. Alright, so we did that. Showed you guys the other names for them. So you might see these names on a test or in the book at some point. But if you don't like that name because it confuses you, just replace it with sine -1. I'm going to skip that one. All right, this will be the last. I think this will be the last thing we do for today. We've talked about doing unit circle trig. Okay, when we did unit circle trig, what was the radius on the circle? 1. Okay, and I may or may not have told you, but whether you do it on a circle of radius 1, 2, 5, or 20, it doesn't really matter. Okay? We can extend the 6 trig functions that we already know from unit circle trig to a circle that's any size we want. Okay? 1 is the easiest, but if they don't give you a circle with radius 1, we can still do it. Let's say you had a point, let me put a point right there. So there's a point on a circle of radius 1. If this circle was bigger, you could imagine the same point being basically right here. That's at the same exact angle that it is on a unit circle. The only difference is it's on a bigger circle, so it's further out from the center. Let's see if we can figure out what the formula would be for sine on a circle that has a radius of r. And the way we're going to do it is we're going to use the formula that we know from this lesson about sine. opposite over hypotenuse. Okay. So make a triangle, just like that. And let's say we wanted to find the sine. Your reference point is going to be the angle right near the origin. That's your point of reference. What would be the letter we would normally use to describe horizontal distance? Like that. Yeah. Okay, that distance would be x. And what about what we would use to describe the vertical distance? We would use y. Okay, and what would be the length of the hypotenuse on this big triangle?
1 r.
What is it?
1 r.
Yeah, 1 r, just r. Okay, so let's imagine just taking this point, and instead of having it on a unit circle, I want you to move it out so it's right there. So now the length of the bottom side is x, the height of the triangle is y, and the hypotenuse is no longer a 1, it's an r. That's
Is r going from like the center point of the circle to the diameter, or is it going
r is
from-
right there.
Oh, okay. That was from the end of one.
In circle stuff, so
Yep.
basically-
So r is that red line right there.
Okay.
So now think about what sine would be using this triangle. What would the sine be? Yeah?
Y over R.
Y over r. Yes. What would the cosine be? X over r. And what would the tangent be? This one is actually the same as the unit circle formula. Yeah?
Y
Yeah. Go ahead. X.
over x.
Y over x. Yes. So sine is y over r. Cosine is x over r. And tangent is y over x. This one ends up being the same as it was for a unit circle. So we figured all these formulas out using opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. These formulas and the opposite and adjacent stuff is the same formulas. It's just basically using a different name. That's all. This is basing it off of like a coordinate, x and y. Now, what do we always do to get the other three? Yeah? Find the reciprocal. So the cosecant is r over y. The secant, r over x. And the cotangent, that's the same formula we had on the unit circle. It's x over y. Now, don't do this, but I want you to write down what's on the board. But if you change all these r's to 1's, what do you notice? What are those formulas?
Is the exact same as for unit circle.
Those are the exact formulas for the unit circle. So when I taught you guys unit circle originally, I really taught you these formulas. The only thing I did to make it easier was I let r be 1. Okay? Now you can let r be any number you want and figure out your trig functions. Okay, so now we're going to try finding the 6 trig functions on a circle. May not be a unit circle, but that doesn't matter. We've got formulas now if it's not a unit circle. Everyone have those 6? Yeah? The last slide? Yeah. So that was just kind of a diagram to think about how to figure out the formulas. And once I do this, most people get it right away. Just thinking about opposite, adjacent, and hypotenuse. Alright, so I was going to recall the 6 functions as a unit circle trig. You guys already seem to know those. So we were good. Okay, let's try a problem. It says find the 6 trig functions of an angle where the terminal side goes through the point 2, 3. First, just think of the point 2, 3. Is the point 2, 3 on a unit circle? No. It's past it. If you're not sure, if you're kind of not sure why, well, let's look at this picture. Okay, the unit circle would be kind of like right in here. That's a circle with a radius of 1. We're finding the 6 trig functions of an angle where the terminal side goes through the point, what did I say? 2, 3. 2, 3. So this is the angle that we're trying to find trig functions for. And this is the size of the circle. It's definitely not a radius 1. It's probably not even a radius that's a nice number. Maybe it's 3.6 or something. We have to figure out what the radius is. So if you make a triangle like that, how could you figure out the radius of that circle? Yeah, Rich?
Well, the bottom, the base is 2 and the height is 3. So you Pythagorean theorem.
Base is 2. The height is 3. So yeah, use the Pythagorean theorem, and that will give you the radius of your circle. Okay. Why do you need the radius? Because all the formulas have R in them. So, well, most of them. So you got to find the radius. Okay, what's going to be the radius of that circle? Just as a square root. Square root of, yep.
13.
Square root of 13. Yep. So let's write that down. Radius is square root of 13. What's x? 2. And what's y? 3. Now fill in those numbers into those formulas. Okay. What's going to be my sine of the angle represented by the coordinate 2, 3? Yep.
Can you go back to the picture real quick? I don't remember which one's opposite. So the 3 would be opposite. Right?
Well, you don't even just think of it. I would just think of it like this.
Okay, so then, yes, 3 times the square root of 13 or 13.
3 times the square root of 13 over 13. So y over r. You could think of it as opposite over hypotenuse. It's the same thing. I think it's just easier to think of it this way when you have a coordinate. What's the cosine? Yeah. 2 square root of 13 over 13. And the tangent. Yep. 3/2. Okay, might as well do the cotangent. That one's quick. 2/3. What's your cosecant? Yeah.
13 over 30.
Yep. R over y. Square root of 13 over 3. And what about your secant?
13
Square root of 13 over 2. So that's how you can find the 6 trig functions on a circle that's not a radius of r. But you can kind of think about it 2 ways. You can either think of it like Rich was with the opposite and adjacent, or just think of it in terms of these formulas. It's the same thing. Okay. Right. Any question on that? Okay, so tomorrow we're going to pick up with kind of what we already did, finding the size of the angle in this triangle, okay, using inverse trig. Okay, so not much left, but we'll finish it tomorrow. It's about 3 more slides, I think.
It would have number 1.
Alright, so let me just take a look at the homework for tonight.
Nick.
So let's do you know what, I'll just change it. Let's do 25 to 32. And then, let's see. And then let's do 51. And that's okay, so it's 25 to 32, 40 to 42, and then 51. And we'll take a look at that tomorrow. We do need probably about 15 minutes to finish up the lesson, and then we will have the rest of the class to review.